All right, welcome back, guys. We are on SAT Math Crash Course Day 2, Part 2, just coming back from a break, slightly more caffeinated than before. Let's keep rolling with questions. We're still on, we're practicing rules 1 and 2, plugging in values in place of the variables and using basic logic to eliminate incorrect answer choices. Last was question number 10. So let's bring up question number 12. Ooh, yes. And let's go with Owen. Wait, no. Who did the last one? Was that Jonathan?
Yeah.
We are at Owen. Okay. Owen, read number 12 for me, loud and proud, please. Can you hear me, Owen?
A website uses the formula above to calculate a seller's rating R based on the number of favorable reviews F and unfavorable reviews N. Which of the following expresses the number of favorable reviews in terms of the other variables?
Okay. What are we solving for here, Owen?
We're trying to get F onto the left side of the equation.
Yeah, we're trying to get F by itself, right? So it's a real fancy way, basically, of saying isolate F, right? Which of the following expresses the number of favorable reviews, that's F, in terms of the other variables. Isolate F. Does that make sense, guys? Mm-hmm. All right, and if you look at the answer choices, right, I mean, all of them have F basically by itself on the left-hand side of the equation. So clearly we have to isolate F. Okay, they just be aware of that kind of phrasing that pops up a lot on the SAT. Okay, so we can do some algebra here. We can. Or we can plug in values in place of the variables. I'm half tempted to show you the algebra here. Would anyone be curious to see the algebra on this one?
Yeah, I'd like to see it.
Okay,
Yeah,
it's crazy complicated. Okay,
Never mind.
very few students can do it. Okay, but I want to show you just to compare it to the second way that we're going to do it by plugging in values. Okay, so here's kind of what the algebra looks like. We've got R equals F over N plus F. Okay, now the big problem here is we've got to isolate F, but we got F in the denominator here. So I always start by telling students, get the variable you're trying to isolate out of the denominator. And we're going to do that by multiplying both sides by n plus f. If this makes no sense to you and you can't follow along, don't worry at all. In fact, I'm showing you why plugging in values is so much better than doing the crazy complicated algebra. Multiply both sides by n plus f, right? And so that cancels out the denominator basically on the right-hand side. And we've got n plus f times r equals f. Now you've got to distribute the r right here. Mm-hmm. Okay. We get rn plus rf equals f. Okay. Now at this point, the general strategy, really, you want to get all the variables or all the terms with the variable you're trying to isolate onto one side of the equation. So I would subtract rf from both sides. Okay. And that gives me rn equals f minus rf. This is the part that throws off most students because they don't know what to do with this part right here. I've got an f and an rf. What do I do? The operation here is you want to factor out the f. So f times something in parentheses equals rn. Does anybody know what it is? F times
1
what?
minus r, right?
F times
r
1.
Minus 1.
Yeah, 1 minus r.
Yeah.
Okay? And at that point, then, you divide both sides by 1 minus r. Woo! And then we've isolated f. F equals rn over 1 minus r. Algebra, yay!
Wow.
Does anyone think they could do that on their own right now?
No. Nope.
No, very few. I've maybe taught one student that, and no, I'm not sure if I've even taught a student that could figure this one out on his own.
I have a question about the algebra part, though.
Sure.
Instead of multiplying both sides by n plus f, would you have multiplied the numerator and denominator by n plus f?
The numerator and the denominator. Well, if we did that...
It's like multiplying it by 1?
Yeah, but if we did that, it wouldn't cancel anything out. Because, basically, it would be, we'd have f over n plus f.
Oh, yeah, you're right.
Times n plus f over n plus f. In which case, yeah, it would cancel out in the numerator here and the denominator, but you're left with f times f over n plus f. Does that make sense?
Yeah.
Okay. Let me show you an easier way to solve this problem. Let's come up with a value for n, r, and f. And f, n, and r. Yes, I think I said that right. Okay. And let's do this. We're gonna plug in, and we're gonna make f1, and we're gonna make n1. Okay. Let's start there. Okay. I don't want to start with the value for r. Like, I don't want to make r1. Why would it be really tricky to make r1? It might actually be impossible. Why would it be tricky?
Because it makes the denominator equal 0.
Well, if we make r1 or make r2 or something like that, then I got to come up with values for f and n that would kind of work that would somehow make that work. You know what I'm saying?
You'd have to conform.
Exactly. I'd have to conform f and n to r, which is going to be really, really tricky. But if I start with my values for f and n, simple values for f and n, then I'll just calculate what r is and we'll be fine. It'll be easy. Does that make sense? Okay, I like the way you explained it there. Thank you. Who was that, by the way?
I think that was me.
Who was that? I'm sorry.
Blaze.
Blaze, thank you, Blaze. I love it. I love the way you phrased it. All right, so what is r when f is 1 and n is 1?
1/2, right?
1/2, yeah, 1/2 or 0.5. I'm going to do 0.5. I think that'll be a little bit easier. 0.5. Okay, great. Any questions about that so far? We've set our values.
No.
No? Okay, and then if we look, double check, let's plug this into this equation. Does that make sense? We get 1 over 2 on the right-hand side of the equation, which is 1/2 or 0.5, so we're good. Okay, great. Now let's plug those values into the answer choices right here.
Yep, it's called Plug On
Okay,
Here.
and who are we on again? Who is working this one out?
Owen.
Owen? Great. Owen, let me see you plug these values into answer choice A. Can I see you do that?
Yeah.
Okay.
Because n equals 1. So it's just 0.5 times 1, which...
Yeah, exactly. Does everybody see what he did right here? He's just plugging in the f, r, and n values. R times n would be 0.5 times 1, which is 0.5. And then 0.5 minus 1 right here would be negative 0.5. Does that make sense, guys? Yes or no?
Yeah.
Yes? Any questions about that? What he's doing here, or no? All right. Does that equal 1?
It equals negative 1.
Negative 1. So it's not answer choice A. Don't worry about it. Plug it into B. Okay, Rn is still 0.5. That's good. And 1 minus 0.5, which is 0.5.
And that equals 1.
And that equals 1. So answer choice B is looking pretty good, right, Owen?
Yeah.
Okay. Now, in fact, I think that's what we got when we isolated it using that crazy algebra operation I showed you.
Yeah.
All right. Let's try confirm that using this method here. Let's plug in these values in answer choice C. See what we get.
In C?
Yeah.
Okay.
1 over 0.5, which is what?
2.
2. Okay, so not answer choice C. Plug that into answer choice B for me, buddy. Okay, that's going to be negative. All right, so D is gone as well. Questions about that question?
Nope.
No? Which method do you like more, the first or the second?
Second. Ouch.
That's a dumb question, isn't it? Right? Now, again, you got to pick the right kind of values here. And if you don't know to start with your f and n values, you can't just pick whatever for f, r, and n. Right? It's got to give you a true statement. It's got to work within the requirements of the question. But as long as you do that, this is still the easiest way to go by far. You got a good shot at it doing it this way. Doing it with the algebra, I mean, I've literally spent like hours of tutoring with some students, like practicing isolating variables. But none of that's necessary if you're just dealing with actual values. You're doing arithmetic. Okay. All right. Are you guys starting to see how this test is actually really doable with your current skill set?
Yeah.
If you approach the questions the right way. Totally doable. Great job there, Owen. All right, so we are at Annika. Can you hear me, Annika?
Yes.
Okay, great. Go ahead and read question number 14 for me, please.
A radioactive substance decays at an annual rate of 13%. If the initial amount of the substance is 325 grams, which of the following functions F models the remaining amount of the substance in grams T years later?
Okay. Okay. How can we solve this by plugging in some values for T? Any thoughts?
Well, first we put in the values and then just plug it into the variables.
Yeah, plug it in for the variables and the answer choices. Let's talk about what this would look like first. If we're talking, let's plug in like a 1 for T. Right? Can we do that? After 1 year.
Yeah.
How many grams would you expect to have left if this substance is decaying at a rate of 13% per year? Well, just give me like an estimate of like how many grams would be left after 1 year?
Wait, can you say that again? Sorry.
Yeah, so like just kind of logically, if this radioactive substance is decaying at a rate of 13% per year, like what would a reasonable estimate be for the amount of grams left after a year?
Like based off of the.
I'm just saying, like, just based kind of, yeah, just logically. Just give me a guess. I mean, something around, like, it's going to be less than 325, right?
Yeah.
It's not going to be like half of 325. Like, I mean, like 300 maybe, or like 280 or something like that. You know what I'm getting at? Like, I don't know exactly what it is, but I'm not worried about that, right? I'm just saying, like, if we're going to kind of feel this thing out, what kind of values I would expect to see when T is 1. Does that make sense?
Mm-hmm.
Okay. All right, so let's do that. Let's plug in a 1 for T into answer choice A. Let's see what we get.
Okay.
All right. And by the way, 0.87 to the power of 1 is just going to be 0.87, right? So it's literally just 325 times 0.87. Go ahead and calculate that real quick.
So, so the first.
Yeah, for answer choice A. Does it make sense how we're testing answer choice A, or no?
A little bit.
Okay, no problem. I'll guide you through it. So here's what I'm saying. Just we're gonna plug in a 1 for T. So it's gonna be 325 times 0.87 to the power of T. But remember, we said T is 1.
Yeah.
Right. So to the power of 1. What's anything to the power of 1?
The 1.
Not 1. Mm-mm.
Or the 87 or whatever.
Yeah, 0.87, right? It's anything to the power of 1 is itself, right? X to the power of 1 is X. 325 to the power of 1 would be 325. 0.87 to the power of 1 is 0.87. So,
yeah.
Okay, so all this is 325 times 0.87. Do you have a calculator, Annika, by any chance?
Yes, I do.
Okay, go ahead and multiply that out real quick. Let's see what we get.
282.75.
282. So 282 point what?
75.
0.75. That sounds pretty good based on our earlier estimate, right?
Mm-hmm.
Okay. Okay, so I don't want to eliminate A yet. Let's plug it into B. And we'll do the same thing. We're just plugging in a 1 for T, so we get 325 times 0.13 to the power of 1. What does that give us, Annika?
325. Um, 13,000?
Shouldn't give us 13,000, right? It's going to be less than 325, right?
Let me do that again.
Yeah.
325
times 0.13.
times 0.13. There we go, 42.25.
42.25. What do you think about answer choice B?
That seems really, really low.
Yeah, that's not a 13% decrease, right?
Yeah.
That's crazy, right? And I think I'm kind of seeing now where they came up with that value. That's probably what the decrease is, right? Is by multiplying it by 0.13, that'll tell you how much it decreased, but it won't give you the remaining amount right? Which is what they're asking us to solve for. So I would eliminate B. Does that make sense, guys, why we can eliminate B very comfortably?
Yes.
Yes? Okay. All right, so let's plug a 1 in for T and answer choice C. So we'll get 0.87 times 325 to the power of 1. That's just 325. What does that give us?
282.75.
282.75, okay. Just like A. What do you want to do? Do you want to keep C or eliminate it?
For now, keep it.
For now, let's keep it. Yeah, I don't want to eliminate
Yeah.
it because that's a reasonable value. And
Yeah.
then plug it into D. Same thing. 0.13, 325 to the power of 1.
Equals 42.25.
All right, same as answer choice B. Eliminate it?
Yes.
Yeah, definitely eliminate answer choice D. Okay, so we've got A and C. Okay. Now, how can we decide? How can we determine which one's the correct answer choice here? Any thoughts?
Sure.
Well, it's decaying at that amount each year, so T is the amount of years. But if you plug in like 2 for A, then
Yeah.
it decreases more.
Yeah,
If you
is it-
put 2 for C, then it gets bigger.
Yeah,
I would
yeah.
say
Let's
A.
let's do that. Let's plug in. You're absolutely right. Let's plug in another value. Let's plug in a 2 for T. Okay. Plug in a 2 for T. So 320. We're going to testing answer choice A again. 325 times 0.87 squared, right, to the power of 2. Now, here, the important part here, you've got to square this first. Right? You're not multiplying 325 by 0.7 then squaring it. You're squaring 0.87 first. So do that and then multiply that by 325, see what we get.
So 0.87 squared.
Uh-huh.
Weird number. Then that times 305. 248. 245, excuse me.
245?
9.
Okay.
Yeah.
Does that seem like a 13% decrease after 2 years? Does that sound reasonable?
Yeah.
Yeah, it sounds reasonable. Plug that. Let's plug that 2 in for T in answer choice D or C. Sorry. So 0.87 times 325 squared, and I can already see, right? Just like, was that you,
Yeah.
Jonathan? Earlier?
Yeah.
Yeah, that's going to be huge, right? I'm just curious what that is.
It's like 91.
Whoa.
It's 91,893.
That's crazy, right? It's suddenly shot up dramatically, right?
Yeah.
That's definitely not a 30% decrease. It's a dramatic increase.
Substance decaying doesn't usually add to itself.
No, they don't. Not like dramatically like that. Yeah, I mean, imagine after 3 or 4 years, right? I mean, it's just it's going to be insane. So we can easily eliminate C as answer choice A. Does that make sense?
Yes,
Everybody's going to pick B on this one. Why is everybody going to pick B?
because it looks like it's decaying.
It
at
looks
like
right. Yeah, you're like,
13%.
oh, 13%. Oh, there's a 13 in there. Okay, great, right? I mean, like, on the surface level, it looks so reasonable. But when you're dealing with real values, the correct answer is always clear. It's always clear when you're dealing with real values. Does that make sense?
Yes.
Okay. On the last day, day 4, we're going to go over percent increase and percent decrease just because it pops up so frequently. But you don't even need to fully understand percent increase and decrease here when you're dealing with just actual numbers. Okay? Another really easy way to eliminate incorrect answer choices would be to plug in a 0 for T. Right? We wouldn't even need to punch anything into the calculator. Right? Because what would a 0 for T would mean that no time has passed. Right?
Yeah.
No time has passed. And if we plug in a 0 for T, we can easily eliminate which answer choices right off the bat. By plugging in a 0 for T.
I say
Oh.
B and D.
I don't know about
And
B,
maybe even C.
because B would give us 325,
Mm-hmm.
right? Which after no time has passed, right, then a substance with 325 grams would have 325 grams. So I wouldn't eliminate B. That's reasonable.
Okay.
But I would eliminate C and D
Eliminate-
for sure. Because if I plug in a 0 for T, remember, anything to the power of 0 is 1. So that would be like 0.87 for answer choice C and 0.13 for answer choice D. After no time has passed. Now, the correct answer choice is going to give us 325. Does that make sense, guys, or no?
Yes.
Okay. Questions about that?
Nope.
No? Okay. Awesome. Let's keep going. That's question 14. Let's do number 15. The more we do, the less homework you have. Let's rock and roll. Who is up next? That was Annika. We're back to Ava. Ava, right?
Yes.
Can you hear me, Ava? All right. Go ahead and read question number 15 for me, please.
Alrighty. Expression 5x minus 2 is equivalent over x plus 3 is equivalent to which of the following?
Okay, and what does equivalent mean again?
Means equal to.
Equal to, right? You tell me right now how we're going to solve this. You know how to do it.
So we're going to plug in values in.
Great, let's do it.
For variables.
Great.
So, let's see. I'm looking for one that would be... Maybe just one?
Great,
Or one
I
word?
love it. I love it. I mean, always start there. It's not going to hurt you, right? And again, right now, we're just practicing. We're doing untimed work right now. There's no rush. Make x1, make x0, make x2. You're not going to go wrong.
Alrighty.
All right. So what does that expression equal when x is 1?
So that equals 5 minus 2 over 1 plus 3.
Mm-hmm.
So that's going to be about 3 over 4, I think.
It is. That's it exactly. Does that make sense, guys? When x is 1, that expression right there is going to equal 3 over 4. Does that make sense, yes or no?
Yes.
Okay, we're just doing the arithmetic there. 5 minus 2 is 3, and then 1 plus 3 is 4, so 3 over 4. Okay, great. Now what do we do?
Now we can eliminate the different answer choices.
Yeah, right. Let's test answer choice A.
I don't think answer choice A is going to be the same, because that's equals to 3 over 3.
Yeah, it's just not going to be 3 over 4, so A's gone. That's easy. What about B?
I don't think B is going to be it either, because it's just going to be just over 4.
Yeah, this is where I love thinking in terms of just pure logic right now. You don't always have to calculate this stuff, right? We're taking 5 and we're subtracting something less than 1 from 5. There's no way we're going to get 3/4. It's going to be bigger than 4, right? Does that make sense? So yeah, I don't have to calculate it. I just know it's not right. B is gone. Does that make sense, guys? Why we can eliminate B just logically?
Yes.
Yeah. Okay. Good. What about C?
The ones who really need a test are C and D.
Okay.
So I'm gonna write this down. 5 minus 2 over 1
We don't even
plus 3. But actually, I don't think that's.
We don't even need to calculate that.
Too,
No.
Yeah.
Because it's the same problem with B. We're taking 5 and subtracting something less than 1. It's not going to give us 3/4. C's gone. It's answer
Alright,
C.
so 5 minus 17 over... I don't know how that works.
Yeah. Well, first, let's talk about this. Would any of you have picked answer choice D here by looking at this problem?
Not at first. I would have considered it, but I wouldn't have picked it.
No. I mean, it just doesn't look like it would be right. And
It doesn't.
not at all. I never in a million years would I just looking at it pick answer choice D. Okay. But let's confirm it. Let's plug in the 1 for X and let's see what we get.
Ready? So that's going to be about 5 minus 17 over 4.
Okay. Now let's stop. We got to talk about adding and subtracting fractions here, right? How do we add and subtract fractions?
I'm pretty comfortable with fractions.
You're pretty good with them?
That's going to be about 4 over 4, 8, 12, 16.
Mm-hmm.
1/4.
Yeah, it's 4 and 1/4, right?
Mm-hmm.
Is that going to give us 3/4?
I think so.
Absolutely.
Yeah.
Absolutely. Absolutely. Another way to look at it, too, is to come up with a common denominator for this expression here, right? So, if we could express 5 in terms of 4, right, which we can, right, because 20 over 4 is 5, right? 20 divided by 4 is 5, right? So that's 5. So 20 divided by 4 minus 17 divided by 4, 17 over 4. And then you guys know how to subtract fractions, right? You just subtract the numerators here, right? So when you're adding and subtracting, you just leave the denominator and add and subtract the numerator. So that's going to give us 3 or 4. I like the way that you did it too, Annika. I love that. I think that's or Ava. I'm sorry.
Ava.
Yeah, sorry.
That's okay.
I love the way you did it there too. I think it's great.
Thanks.
Questions about that?
Nope.
How easy is this test if you plug in values for variables?
Too easy.
Stupidly easy. It's all arithmetic.
It's not cheating though, right?
No, but it's so effective it's almost cheating. But I like that. It's no, it's not. This is 100% legal. It's amazing, right? I mean, it's shocking. But once you look at this test this way, I mean, this is just you guys are going to do. You guys are
It
great.
makes me wonder where I was before now.
What do you mean where you were before?
Like what was I doing? I was like,
Yeah, well, here's what you can see. Look at the answer choices. I love that comment. Like, look at the answer choices. You can see exactly where they're coming up with the answer choices. They're basing, like, answer choice A, they're basing that off, like, common misconceptions about math, right? They're like, oh, I'll just cancel out the X right here and right here, right? You can't do that. Math doesn't work like that. And same thing with B, right? I mean, like, it's just another variation of, canceling out the X's. It just doesn't work like that. It's not how you do it. All right, let's do some more. We are not done. That's number 15. So we are at number 16. Ooh, doggy. All right. And up next is Blaze. Can you hear me, Blaze?
Yes.
Great. Go ahead and read number 16 for me, please.
The sales manager of a company awarded a total of $3,000 in bonuses to the most productive salespeople. The bonuses were awarded in amounts of $250 or $750. If at least one $250 bonus and at least one $750 bonus were awarded, what is one possible number of 250 bonuses awarded?
Okay, great. What are we solving for here, Blaze? Let's clarify that.
A possible number of the bonus of $250 bonuses.
A possible number of $250 bonuses, right? And this is where I think I mentioned this in a previous session. Sometimes I like to just underline the last sentence or underline what I'm solving for. It's always going to be in the last sentence. We're trying to find a possible number of $250 bonuses. Let's forget about algebra here. I want to set up an equation. Nothing fancy. Let's just talk logic here. Okay? We know there's at least one $250 bonus, at least one $750 bonus.
Mm-hmm.
Can we test some values here of $250 bonuses? Right. Give me a number.
I'm not quite sure. What do you mean?
Well, give me a number. Right, we're solving for one possible number of $250 bonuses. So give me a number of possible $250 bonuses.
We can do one possible.
We can do one. Yeah, let's try one. Okay, so we're gonna have a $250 bonus.
Mm-hmm.
Okay. Now, is there any way to add some $750 bonuses to get to $3,000 total in bonuses?
Yes.
Let's try that.
I would say...
So how many $750 bonuses?
I would say to find out, you subtract $250 from 3,000.
Okay.
3,000 minus... minus 250.
All right.
Then that comes out to 2,750.
Okay, is that divisible by
I
750?
I think it is divisible by 750.
Anybody do that with a calculator real quick?
No, it is not divisible.
It is not divisible, right? It is not divisible.
The answer to that is, I believe,
all right.
3.
Yeah. Don't even worry about it. I mean, it's not. Yeah, they're not awarding 3.66666667. Bonuses. It's got to be a whole number, right? Logically, does that make sense, guys? Why we know it's not one $250 bonus? Yes or no? Does that make sense? Okay.
Yes.
All right. Let's try another number of $250 bonuses.
So then, if we do 2, let's try 2.
Let's try
$250 bonuses.
I love it.
Hang on. Let me just finish erasing this.
Don't worry about it. You can just there's plenty of room on the whiteboard. You can just.
Oh, okay. So we have 3,000 minus 250 times 2,
which is
500. So that comes out to 2,500.
Yeah.
And then divided by 750.
Does it make sense, guys, what Blaze is doing here?
Yes.
25.
Questions about it?
Mm-hmm.
Yeah.
That's not divisible by 750. Answer being 3.3333.
Yeah, no, okay, yeah. No, not happening. We need another value.
Okay. Should we try something bigger than just 3?
I wouldn't.
Or should... Okay.
I would try 3 here.
Then we have 3,000 minus 250 times 3, which is 750. And that equals 2,250.
You're doing great.
Which then, divided by 750,
I pray gives us a whole number.
is 3.
There we go! Alright? So
then
what's an
that
answer?
means they gave out 3 $250 bonuses.
That's the answer. Absolutely. I think there's a 3 would work, I think 6 would work, and 9 would work.
Mm-hmm. Here.
They're all multiple of 3.
3,000 minus 9. Yeah. That would work.
Yeah. Does that make sense, guys? How we approach that question? And here's the deal. Look, it's not a multiple choice question, right? So how do we test values, right? I don't even see any variables in the question, right? I mean, there's an unknown number of $250 bonuses. That's what we're testing values for. And we got to come up with our own values. But again, we're looking at it as like an experiment and just kind of playing with the numbers and seeing what works and what doesn't work. But if you do that, you're guaranteed to get it. If you try to set up I'm not even sure how you'd set up the equation for this. I'm just not sure. I don't care. You don't need to. You can just use basic logic for this one and kind of work it out. Does that make sense? Okay.
Yeah.
Questions?
No.
You guys are doing great, by the way. I'm very, very, very impressed. All right, let's do a couple more. So we have less homework. Yeah. All right. Oh, yeah. Oh, yeah. Love this one. Love it. Who is up next? Who is my next victim? I mean, volunteer. I meant to say volunteer. Hudson. Can you hear me, Hudson?
I am.
Yeah, okay. If you don't want to do this one, you can pretend your microphone's not working. Right? I'm just letting you know. You got an easy out. No, you can do this for sure. I promise you. I'll guide you through this. Looks a little intimidating, though. But you can do it. Go ahead and read question number 18 for me, please.
In the xy plane, if 0, 0 is a solution to the system of equations above, which of the following relationships between A and B must be true?
Oh, boy. Oh, boy. Does anyone know how to solve this one?
No.
I'll take that as a no. That's okay. That was the answer I was expecting, really. Here's what I want to do for this one. I want to go. Of course, we're going to plug in values for the variable. Of course, right? That's what we're focusing on at the moment. But let's go to the rules for mathing real quick. And I've got one of the basic concepts on the basic concept cheat sheet directly address this, and this is basic concept K. Okay, Hudson, can you read basic concept K for me, please?
Yes. This point 0, 0, or A, B is on the line or is a solution to the system of equations. Plug in those values for x and y.
Okay. Does that make sense? If they say this is a solution or this point is on the line, those are possible values for x and y that give you a true statement. Always. Right? They're kind of begging you to plug in a 0 for x and a 0 for y. Do you see that now?
Yeah.
Right? They're begging you to do it. Why don't they just tell you to do it? I don't know. They want you to know. They want to see if you understand that if you plug in 0 for x and 0 for y, you get a true statement. But you do, right? If it's a solution to the system of inequalities. So Hudson, why don't you plug in a 0 for x and a 0 for y into these inequalities here, and I want to see what happens. I want to see what we get if we do that. Can you do that for me, buddy?
Yeah, you just get you just get y is less than 0.
Remember, we can plug in a 0 for x and a 0 for y. Well, hold on a second. Hold on. Let me show you what this would look like. So, does it make sense why this ordered pair, 0, 0, that's like an x and y value?
Mm-hmm.
Are you guys familiar with ordered pairs?
Yeah.
Right? Okay. So basically, when x is 0 and y is 0, we get a true statement for these systems of inequality.
Oops, actually.
So, you're plugging them in for a and b.
Yeah, my bad.
Something else. Yeah. So, try it again and plug in 0 for x and a 0 for y. Well, you're still plugging them in for a and b here, Hudson. Let me show you what it would look like real quick. So I'm going to take the first inequality. And remember, y is 0, so I'm going to plug in a 0 for y. 0 is less than negative x, which would be negative 0, okay, plus a, okay? And then in the second inequality, same thing, 0 is greater than, and x is 0 as well, 0 plus b. Okay? Stop, take a look at this right here. Does it make sense what I've done there?
Mm-hmm.
Yes or no, guys?
Yeah.
Make sense? All right, I've just plugged in 0 for x and 0 for y. Recopied the inequalities. Hudson, can you simplify that for me? Or no? Absolutely, right? Yeah, a minus 0 is just a. Great. So 0 is less than a, but 0 is greater than b. Another way to look at that is a is greater than 0, but b is less than 0.
So
it just be C, right?
Well, we're going to test the answer. We're going to test the answer choices here in just a minute. But let's look at this. Let's look at this. Okay. If a is greater than 0, Hudson, a's got to be positive, right? If a is greater than 0.
Yeah.
Right. And if b is less than 0, b's got to be negative, right?
Mm-hmm.
Okay. Okay. Now let's look at the answer choices. Go ahead and look at answer choice A.
Okay.
Does A have to be true? Because the question is, which of the following relationships between A and B must be true? Does A have to be true?
Yes.
Yes.
It does. Answer choice B, which says B is greater than, must be greater than A. Is that a true statement, yes or no?
No.
That's an impossible statement, right? If B is negative, right, and A is positive, which it is, it has to be according to this right here, then B is impossible, about the opposite of true. What about C? Does C have to be true?
No, because that would make B a positive, and it has to be less than 0.
Yeah, could you come up with values for A and B that would make C incorrect? Do you know what I'm saying here?
Yeah. You could put A as 1 and B as -2 to make it incorrect.
It would be incorrect, absolutely, right? Because the absolute value of -1 would be 1, and the absolute value of -2 is 2, and 2 isn't less than 1. So C is gone. Does that make sense, guys, how we can eliminate C logically?
Yeah.
Yes.
Okay, because we can test values. What's that?
You don't even need to find values for A and B. You just know that B, as a negative, its absolute value would be greater than 0, which it can't be.
Uh-huh.
So, yeah.
Okay, yeah. I think I get that. Actually, I'm not sure I do, but Did that make sense, guys? What he just said, Jonathan just said. I didn't catch that. Okay. As long as that makes sense to you, we're good. That's right. Clearly, I need more coffee, tea. Okay. And then what about answer choice D? Can we eliminate that?
Yes, I can.
Yeah. Same. Again, we picked different values. That just doesn't have to be true. Very simply. So that is gone. We can confirm A. Any questions about that?
Nope.
Is that doable by plugging in values for X and Y, and for A and B for that matter? Is that doable with actual values?
Yes.
Totally doable. Theoretically, I wouldn't even know where to begin, theoretically. I wouldn't even know where to begin. But that's okay, we don't have to. Okay. Let's do some more. And let's clear that. Number 18, let's do number 19. Oh, I love this one so much. This is one of my favorites. And we are up. Who is up to bat? It is Hudson. You just read for us, Jonathan. Jonathan, read question number 19 for me, please.
Okay. A food truck sells salads for $6.50 each and drinks for $2 each. The food truck's revenue from selling a total of 209 salads and drinks in one day was $836.50. How many salads were sold that day?
Okay. This is supposed to be a systems of equations question. Is that clear, guys, or no?
Yeah.
Maybe for some of you. You've done systems of equations, right? You've got two variables and two equations with two variables, right? They kind of want you to set it up like $6.50 times the value for S plus $2 times the value for D equals $836.50. Is that familiar at all to some people? Okay. Here's the problem with that, is that everyone jacks up the systems of equations. Everyone messes it up. So there's a much easier way to do this with testing the answer choices. A much easier way to do this. Let me kind of guide you through this one, Jonathan.
Okay.
I'm going to make a little T-chart. I like to do this when we're testing values, especially with two variables. So we've got a value for the salads. We'll call that S. And a value for the drinks. We'll call that D. Okay? And let's test answer choice A. Okay? How many salads were sold that day? If 77 salads were sold, how many drinks were sold?
Lots.
A lot. We know the number. We can calculate it pretty easily.
Yeah.
How do we find the number of drinks?
Subtract 77, 209.
Yeah, and what is that?
Big number. What is it? 209. Just a second.
You're good. Does anybody know what it is? It's just
It's
209.
132.
132? Is that right? 132?
Yeah.
Okay, good. So if 77 salads were sold, 132 drinks were sold that day. Does that make sense why? Or are there any questions about this so far?
Yeah, that makes sense.
Questions about it?
Yeah.
Anybody else?
No.
No? We're good? Right? Because we know 209 salads and drinks were sold. So if we know the number of salads, we know the number of drinks. Okay. Let's talk about how much revenue was brought in then. If we sold 77 salads, how much total revenue was that?
That's 77 times 2.
No, well, hold on. The salads were $6.50, right?
Oh, yeah. So
it should be 77 times $6.50.
500.
500. Even?
Dollars.
Even?
And 50 cents.
And 50 cents. So $500.50. Okay. And then, sorry for the bad handwriting. And then how much revenue in the drinks?
So that's, I guess I don't really need a calculator for this.
Yeah, you can probably do that one.
264.
264. Okay. And then when we add that together, that should give us $836.50 if it's the correct answer choice. Do we get $836.50?
No.
No, we get 700 something or other. Right.
Yeah.
So we don't even have to worry about answer choice A. Gone. Does that make sense how we eliminated that?
Mm-hmm.
Okay. Any questions so far?
No.
Okay. This works for almost every single systems of equation question. You can solve this way. All right. Let's try 93 salads, right? Because they're asking how many salads were sold. So let's test answer choice B, 93 salads. If 93 salads were sold, how many drinks are we talking about?
116.
Let's talk about the revenue. How much from the 93 salads?
93. That's 604.5.
604.50.
$4.50.
Okay. And then how much from the drinks?
That's 232.
Does that give us 836.50?
Yes.
Booyah.
Easy money.
Easy. Questions about this?
No.
It's still not cheating.
I'm a little confused.
Yeah, go ahead.
How did you get the number of the number of drinks from the number of salads?
Because the question says the food truck's revenue from selling a total of 209 salads and drinks.
Okay, never mind.
Yep.
Thanks.
So we know when we add them up, we get 209.
Yeah, I think I get it.
Okay. Questions?
Nope.
Is this cheating?
Seems like
Almost feels like it.
Almost.
Borderline.
I like it.
Oh, but I love it so much. And this is the way to do it. This is the way to do it. Even if you're kind of good at algebra, I'd steer all my students away from trying to solve this. Because all it takes is like, you miss like a negative sign somewhere. Or like, we just make silly errors with algebra that you would never make when you're dealing with real numbers. Because like you're feeling things out logically. And you always catch yourself if you're off when you're dealing with real values, generally. You catch yourself.
Yeah, I remember one question on the SAT that I took, and it was like that one we did earlier with the real complicated algebra.
Yeah.
I like wasted a bunch of time on it because I didn't know how to like separate the
Yeah.
or whatever.
Yeah, that's killer, man. I mean, if you find yourself spending more than like a minute and a half on a question, just skip it.
Mm-hmm.
Come back to it. It means if you can't figure it out, it's just a really high level difficulty question that you're probably not going to get anyway, right? If it's a really tough one, the chances are you're not going to get it. So why spend all your time on the ones you're not going to get, likely, and then not get to the ones you can get for sure if you just spend the time on them, right? So, and we'll talk about that strategy again the last day 4 session. But that's the key, is just don't waste your time on the really, really tricky ones. Okay. Let's do one more, then we'll wrap it up. Let's do... That was 19, so let's do 25. I like this one. All right. Was that you, Jonathan? You did the last one? So we are at Owen, right? Owen? Can you hear me, Owen?
Yes.
Okay, great. Go to read question number 25 for me, please.
The equation above expresses the approximate height h in meters of a ball t seconds after it is launched vertically upward from the ground with an initial velocity of 25 meters per second. After approximately how many seconds will the ball hit the ground?
Yikes. What are we solving for here, Owen?
We're trying to get h.
Read the last sentence of the question again.
Oh, well, and we're trying to get how many seconds, so it's t, but like...
Yeah, after how many seconds will the ball hit the ground? That's the question.
Yeah.
And then the answer choice are all potential number of seconds when the ball hits the ground. Okay, now, don't get into h. The height is a factor here. But what's the height of the ball going to be when it hits the ground?
0.
It's going to be 0, right? Does that make sense, guys? Why we know the h value is going to be 0 when the ball hits the ground? Yeah? Does that make sense?
Yeah.
All right, so let's just plug in the answer choices and see which one gives us 0 or something close to 0. Does that make sense?
Yeah.
All right, so go ahead and plug in that 3.5 for t, and I'll write it out. But I want you to calculate it. You have a calculator nearby?
Yeah.
Okay.
So...
Remember, you got to square that 3.5 first.
So 60.025.
Okay, is that 0 or close to 0?
that's the first part.
Oh, I'm sorry. Okay, I see. Okay, I see what you're doing now.
Plus 100, and it's about 40. So no.
Not super close. Let's try B. Okay, I'm gonna clear this as well.
And then 78.4.
Now this should be negative, right? Negative 78.
Yeah, negative.
0.4.
So that's still a little bit more than 0.
Yeah,
so.
we're getting closer. That's like
Yeah.
20, 1.6 or something. Okay. Let's try C.
Alright. 99.
So they have not equivalent exchange, but they're so, and I would say that
So that sounds closer.
What is it? What is that?
112.5 plus negative 99.225.
And what does that give us?
About 13.
Okay, we're getting closer.
Yeah.
Let's try D.
I mean, at this point, since all the other ones are wrong, you'd just automatically do D, though, right?
D is looking good, but notice it says after approximately how many seconds.
Oh,
So it's not going to be
so-
exact, right?
Mhm.
So let's plug in D to be safe.
And then after calculating this, it's 2.5.
2.5.
So the closest is D.
Closest is D. Questions about that?
Nope.
It's pretty much just putting the values in the calculator, right?
That's it. That's it. You don't have to solve for T on your own. Just test the values, test the answer choices. That's all. Now you got to make the recognition that H is 0, but I think most of you could probably do that. Right. Any questions?
Nope.
No?
Nope.
Okay. Guys, every single one of these questions, these are real questions from real released SAT practice tests. Made by the College Board, made by the guys that write the SAT. I just saw a recent version of the SAT that was administered on Wednesday. I saw some of the math questions. These exact same questions, these exact same style of question, exact same skill set, exact same concepts. This is it. This is it.
That's good.
So, this is totally doable. Now, again, there are some more specific concepts. You know, they test you on, like, do you know, like, how to graph, the equation of a circle, and you got to know, like, radians and degrees and stuff like that. I'll probably be offering another, like, level 2 course that gets into the more specific concepts. But for the vast, again, this approach works for well over a third of the questions on the SAT. So, with your existing skill set, this is generally enough, certainly to get a big score increase if you approach it this way. Okay. All right. So for homework, I'm gonna we'll do the rest that we didn't get to today. I'll send that in a Google Doc in an upcoming email. The next class we'll go over the homework and a little more plugging in values in place of variables. We'll change the pace a little bit. We'll start with some of the geometry. But again, I approach the geometry the same way. It's all about simplifying the questions and using basic logic. You don't have to know any fancy equations or anything like that. You really have to do very, very little algebra. Oh, hello, puppy. Yeah, Daddy's tuning right now, okay? I'll see you in just a minute. Sorry, my 2-year-old. Yeah, all right, so shocked it hasn't happened yet. Okay. Any questions?
No.
No? Okay, awesome. Guys, thank you so much for your participation, for your hard work. Make sure you try the homework. I can't emphasize it enough that you've got to be able to practice these skills on your own. I'm showing you the playbook. You got to put the reps in. Okay? All right. Well, thank you so much, guys. I look forward to seeing you all next week. All right?